Good afternoon, boys and girls. Okay, let us continue the chapter heat, and we are on the topic methods of heat transfer. Okay, so there are three methods of heat transfer, that is conduction, convection, and radiation. Now, what is conduction? Conduction is in solids. Okay, so in solid, if you supply heat to one end, suppose it's a metal rod, you are putting the rod on a flame at one end, the other end also uh, gradually gets heated up. Okay, so the heat transfers from one end to the other end. So the whole rod becomes hot by the process of conduction. Actually, the heat transfers by vibration of the particles. Okay, so there is no actual movement of the particles, but only they vibrate. Okay, the particles where you supply heat get energy, okay, and start vibrating, and then the particles which are in contact with the vibrating particles, they also start vibrating, and so on. This vibration or the energy passes on, and by this process the heat is conducted to the whole body. So this is the process of conduction. And now convection. Convection takes place in liquids and gases. Okay, so here there is actual movement of the particle. Okay, when we supply heat, suppose you are heating water, so the water which comes, so you are supplying the heat at the bottom of the vessel. So the water at the bottom which comes in contact with the heat, okay, it gets the energy, and when heated up, it expands. Okay, the molecules expand, so they get energy, and expands. The density becomes less because of the expansion, or because of the kinetic energy they have gained. The heat energy, it's converted into kinetic energy they have gained, and that's why the density becomes less, and they become lighter, and they move at the top. Okay, so the hot water raises to the top, and the cold water replaces its place. So it comes at the bottom, and again it's get heated up by gaining the heat, and so again it moves up. So that's how there a convection current is formed. Okay, and it moves in a cyclic order. Okay, so uh, the heated water goes up, and the cold water from the other parts comes down. So this cycle goes on until the whole water gains the energy, and the whole water gets heated up. Okay, now this same process is used by the nature also, and if you are in a coastal area, there are land breeze and sea breezes. Okay, so how these sea breeze and land breeze are formed. Okay, during day, due to sunlight, uh, water absorbs, both are getting the same heat from the sun, but specific water, specific heat of water is more. So it very slowly it's get heated. It's heated up very slowly, and land becomes absorbs the heat and it becomes heated up fast. Okay, because only the surface of the land is becoming hot. It is only gaining the heat. So it becomes hotter than there is a difference in temperature. Okay, so the land becomes hotter than the water. So the air in contact with the land, or here, or you can say air above the land, becomes hotter than the air over the sea. So the air becomes lighter or less denser. The density becomes less. So it rises up. Lighter air rises up. And when it rises up, the air, a vacuum is created, or a low pressure area is created. So the air over here moves to fill the gap. Okay, so this process goes on, and during daytime, sea breezes come to the coastal areas, flowing to the coastal areas. And it's just the opposite during the night time. Night time, again, the heated water gets very slowly it cools down, whereas land cools down very fast. Okay, so again, the air over the sea, there is difference in temperature. The water is hotter than the land. So the air over the water or the sea becomes hotter and then lighter, of less density. So it moves up. And again the air over land blows air to fill the gap. Okay. So it blows, keeps on blowing, and that's called the land breeze. Okay, so these two types of breezes are there due to the convection. Okay. Now the third method of heat transfer is radiation. So radiation, it does not need any medium for heat transfer. Okay, for example, from sun, heat is coming to earth, but it does not need any medium. You know, there is a space, empty space in between. So much empty space is there between sun and earth. So it is coming through that also. So because it does not require any medium. Actually, it is an electromagnetic waves. Okay, by radiation, the heat comes in form of electromagnetic waves, so which do not require any medium. So these waves come.
Good morning, sir.
Yes.
Good morning, students. Good morning, sir.
Okay. So does not. Okay. So. Okay, in practical life also you must have seen in winters we use heat radiators in our homes. Okay, there is a halogen light, halogen lamp is there, rod is there, and a reflector is there. So the heat comes by the reflector to us through radiation only. Okay. Okay, that was the third process. Okay, now we have vacuum flask or a thermos flask you are using also for hot water or cold also for tea and coffee. So these thermos flasks are used in our homes also. So how do they remain the water or the tea coffee remains hot for so many hours or the cold water remains cold for so long? So here, look at the construction. Here, it's a double wall. Okay, two walls are there. One is outer and here is the inner wall. And all the air from inside these walls is taken out. So there is no air and then it's sealed up at the ends. So no air is there. So when no medium is there, then heat cannot transfer from here to outer surface or the atmosphere by convection or conduction. So no medium is because these two processes require a medium. Now the heat can be lost or gained only by these three processes. The third one is radiation. So to make these walls are plated with silver. Okay, these are glasses, in fact. Okay, there can be other materials also used but for very good thermos flask, glass is used and silver polished. Okay, so they are because silver does not it does not allow radiation. Okay, so it will radiate back the heat over here only. It will remain here. So very very less amount of heat is transferred by radiation. Okay, so it remains over here only, heat by this silver glass, reflecting it back here only. But still some loss is there. Anyway, by where here stopper is also made up of atom non-bad conductor fluid, so it also maintains the heat inside the bottle. But still, when we open the bottle or some loopholes are there, so there is a loss. So it can keep the heat for a few hours and not very long, not for many days. So these are by just reducing the heat loss by reducing these three processes, we maintain the heat over there, and you can see. Okay, this is vacuum here, and you have also to construct it. You have to learn how to construct this bottle. It will come in your exercises. So that's all about this chapter. If you have any difficulty, you can ask me. Okay. Now, do the exercises, fill-ups, and these all exercises, and find the question answer. And if you have any problem in finding the answers, you can ask me.